Question 17 is to find the volume by the method of washers. It is very important which method is used because the question number 3 is same problems but it is method of discs. In this video we will see the difference between both of them. Method of washers is when a hole is created. As you can see, this is the details. Now imagine this is the part of the given equation, given graph that is being revolved along the x-axis. So what happens? This part is turned over here, it comes up, and this happens, right? But you see, we are considering this as a circular cross section. So this entire thing over here is a full circle. But as you see, as we move from here to here, there's a hollow space that is generated. See, this is the hollow space that is being generated. So what do you understand by this? This hollow space is something that is not required. Now if you look in such way, over here there is a hollow space at one particular cross section. Okay, imagine this is the cross section. So I need to find this volume only. So what I do is I'll find the total volume, that means the entire thing, and I'll subtract this part. Whatever is this, I'll just subtract it off. That time I'll get whatever is outside. So this is the formula. It is the outer radius minus the inner radius. That is how we can find whatever is only formed. Okay, the hollow space is removed. The hollow space created makes it a washer. Washer is having something hollow in the middle. Now we need to understand which formula to use depending on the question. So depending on which axis it's being rotated, if it's along the x-axis, okay, it's rotated along the x-axis anyway like this, or y is equal to 2, 1, 3, or along the x-axis. This is the x-axis. You use the first formula, and over here the limits, right, is along the x-axis itself from here to here. Whereas if it's along y-axis, that will be like this vertically, like say this is the rotation, or along this line it's being rotated, then it will be the second formula. So it's very simple formula: pi, definite integral, outer radius minus the inner radius squared, both the radiuses, dx. So we will see a problem here. Now what you need to do is let R be the region bounded by the graph over here given. These are three graphs. Compute the volume of the solid form by revolving about the x-axis. Now let us solve this up. Now this is a basic graph that we are going to use. Let me just draw a simple graph. X squared means it's a parabola. X is 0 here, so it's this vertical line. Okay, if it is x is equal to 1, it would be a vertical line, so I'll just consider this. That is a very bad line, so just remember this axis. And y is equal to 1. Let's imagine this is at 1.1. So this is being revolved. Where is it revolving? About the x-axis. So here. So this thing forms something like this. As you can see, this is what is formed. We just now saw the figure. Now here what happens is, if you see this extension, it will be like a circle over here, and this circular region, the washer region, it varies. If I'm considering this part, it's almost full out. If I consider somewhere over here, this over here is the hollow region. Somewhere over here like this will be the hollow region formed. Since we are revolving it, it rotates. This part keeps on coming up and it rotates. It becomes like a circle. So that's the thing. We need to imagine this, and then we need to understand this up. And now what we do is we will try and solve it up. What do we require? We need to see from the figure which is the outer radius. Now, since it's along the x-axis, it's very simple. Outer radius is this flat line, right? Outer radius is capital R. That's 1. What is the inner radius? It's an equation. It varies. At each point, it varies. So it's given as this equation. Inner radius is given as 1/4 x squared. Okay, this much is fine. It's revolved along which axis? Along the x-axis. That means like this. So which formula do we use? Now here it is very important. Now you can look at this and understand. Since you're rotating along the x-axis, you need to consider the limits on the x-axis itself. Now this along the x-axis means the formula will have dx. Now everything must be in terms of this. Now what you need to understand is, we know the limit x is equal to 0 is considered. Okay, this is 0. But where is the end point? Where does this touch? This is at 1, right? And now you can see this equation will touch over here. So this x point is also required. Why? Because we need to take the limits. 0 is the starting point. Yes, okay, that's fine. But we know y is equal to 1. We don't know where it ends at x. So this is an issue. So what you need to do is, you need to find this intersecting point over here, this point. How do you find this? We need to equate this. What is the equation over here? Y is equal to 1, and over here we have y is equal to 1/4 x square. Let us solve this up. 1 is equal to 1/4 x square, and if you take this to the other side, it's going to be 4 is equal to x square, or x squared is equal to 4, x is equal to plus or minus 2. So this is what we need to solve for. I mean, this is what we get over here. So this x over here is 2 and minus 2 is somewhere over here. We won't take that because we're not considering the left side, we're just considering the right side. This is it. Now what next would we do? Here we found the intervals 0 to 2. We know the outer radius, we know the inner radius. Just put it in the formula and solve it up. So I'll just use it over here. Integral. So pi is outside, volume is equal to pi. Integral 0 to 2. Outer radius, it's 1 minus 1 squared, sorry, minus the inner radius. What is the inner radius? It's 1/4 x square. This is entire square, sorry, dx. Put this in the calculator and you will get the answer. Let's have the calculator with us. Now all you need to do is write pi first. Pi integral, it is 1 square minus, now here because we have to square it, remember use the bracket, that's 1/4. Wait a minute, I just realized that I've written this wrong. It is 1/4 x squared. The equation is 1/4 x squared and then again the whole square, okay? Because the formula itself tells you it is outer radius square minus inner radius square. RORI integral a to b, outside is pi, and this is dx, right? Now this is the entire thing will be squared here, okay? So 1 square, that's fine, 1 and squaring. Now here 1/4 x square, the whole square. I hope that is clear. So I'll just write alpha x square, close the bracket, and over here first square it, then close the bracket, again square it, and the limits are from 0 to 2, and that's the answer. It is 8/5 pi, or it's 5.02. So we will see the answers over here. You can see this is how it happens. Now 1/4 x square and x squared by 4 is the same thing, so that's how we get it. Now we got two values of x, so we ignore the left side because we're considering only the right side here, so that's the thing. And here the limits are given, and then we put it in the formula and we solve it up. 8/5 pi, or 5.03 unit cube. Why? Because volume is in terms of power 3, the dimension. So it will be, if it's centimeter, it will be centimeter cube, and so on. So that's how we solve this particular problem, and we can solve other problems. Now we will just go through this and then we will go through these problems and solve as well. Same sketch, same graph, but it's not along the x-axis. Now we are rotating, it's along y is equal to 2. See the same graph which we just now got. Over here they have given y is equal to 1, so this is cutting out, and then x is 0, so this is the part, and then what do we have is 1/4 x squared, so this is the thing, okay? This is what we are rotating here, not along x-axis, not like just now what we got, along the line y equals 2. So you can see this is the line y is equal to 2. Over here it's been rotated. Now what is the issue if we rotate it over there? There is so much space, right? The same thing, now when you start rotating it, this part comes up, so the same space is left hollow over here also. Now this was how much? From 2 to 1. The line they have told y is equal to 2, and we know it cuts at 1, line y is equal to 1, so much will be 1. It's very simple. Same thing over here also, there will be 1, and then we will have a straight line. and then over here also the straight line, and then this thing. This is how the figure actually is, and this is the hollow space formed. So now we are not going to consider both the sides. We're just focusing on one because we are considering radius. If we consider the entire thing, it will be diameter. We're not taking in a diameter, we're taking in a radius. So from this rotation point, where about which line we are rotating, right? From here to the inner part. Now, inner part is flat, isn't it? It's a flat line. So from here to here, how much is the distance? 1. So that's it. Inner radius is very simple. That is inner radius. Now, the outer radius is very important. The inner radius is easy to find. Look from the point where it's being rotated or revolved. See the outermost point of the figure. It's still over here, right? What is this distance? We know from here where it's rotated from this point to this point, it's 2. But you can see the curve is coming inside, so it'll be 2 minus whatever is this equation. That will be 2 minus, what's this equation of this curve? It is 1/4 x squared. So this must be the outer radius, outer, yeah. Now, if at all it was like this, imagine this is where we rotated, and this one, two, and the curve was going outside like this, just in case. Then we would have taken it as, sorry, it would have been something like this. We would have considered to be 2 plus. We will see such problems. They'll give you specific problems like that. We can easily deduce how to take the outer radius based on that. Now over here, see these 2 points. Okay, from here to here, it's 2, but it's coming inside. So here there is a decrease, right? So we consider minus this equation because it's coming in. So now then we have the outer radius and inner radius. So the formula is very simple, pi limits. The limits are going to be the same because we just now solved it. It will be from 0 to 2. And how do you solve it is very simple. Just solve these 2 equations, you'll get it. And then what do we have is outer radius. So outer radius is 2 minus 1/4 x squared, the whole square, minus inner radius is 1 square. This entire thing with respect to x. And what will be the answer? We will do it in the calculator. I've just typed this equation in the calculator. You can see it's pi's, limits 0 to 2, 2 minus 1/4 x squared, the whole square, minus 1 square dx. And when you press equal to, the answer is over here. So let's look into this problem. Here you can see this is what happens after it revolves. This is the hollow space formed. And over here, this is the outer radius, inner radius, and limits are again 0 to 2. And you solve it up. And yes, 56 by 15 pi is what we got. It's 11.73 unit cube. Please do try the problems, other problems by yourselves. Now here, let us see the difference between which is the washer and which is the disc. Here we have a problem of region being bound at 2 minus x, y is equal to 0, x is equal to 0, about x-axis and about y is equal to 3. So now over here they have just given the answers, they have not done the figure. So let's do the figure and then understand. Here for the first one, it's very important to understand the basic graph. 2 minus x, it's basically like minus x plus 2, so wherever is plus 2 is the intercept, and it goes something like this. And what else do we have? Y is equal to 0, so this will be y is equal to 0, this part, and we have x is equal to 0, so it will be this line. So whatever is intersected between, or the region formed within this, this is the region that is being revolved. Where? About the x-axis. About the x-axis is over here. Now if you revolve it along the x-axis, what just happens? Here you're gonna get the same thing down, right? So there is no hollow space formed at all. So this is a disk basically. It is not at all a hollow space, it's just a disk. So just find the radius. Over here y is equal to, this is the radius. So now imagine you have a circle and you just have the radius. It's like there's no hollow space. You just do pi r square, and if you integrate it, you get the volume. It's very simple. Only when there's a hollow space, what you do is, now if you want to remove this, the total, now imagine this is capital R, you do r squared minus pi r squared, the small letter r. because there are two radiuses formed, you want to remove this. That's why we do minus. But now in this case, you don't have to subtract anything because you know the radius, right? What is the radius? This is the radius. What is that equation? 2 minus x. So it will be pi r square. The intervals are need to be found out. How do we find that intervals? From here to here along the x-axis, because it's dx, it's along the x-axis. This is 0, but how do you find this? It's by equating this equation 2 minus x with, what is this equation? 0. So solve for x, x is equal to, goes to the other side, x is equal to 2. So we know the limits are 0 and 2. That's how we get the limits. And then over here, there's only one equation to use because it's a disk. But now the same thing, what we just now found out, right? Here, when it's rotated along y is equal to 3. So I will just change the figure. Let me do it down. This is over here 2, right? Now we are rotating along 3, y is equal to 3. What happens? So here we need to leave a space, and then it goes up like this, like this. So this is formed. When you're rotating, this comes up, right? See, now it's like rotating it. It's more easier to show it, by rotating stuff. Usually I show my students something that I keep my hand as the axis and then I move an object over here like a duster, and it comes up and it creates a hollow space in the middle, right? So that's the thing. So if I consider this as the section, this is the hollow space created. So that is the thing. That's a very rough diagram, but you need to imagine it. Okay, then only you will understand these problems. So here, because this hollow space is created, now you need to realize what is the inner radius and the outer radius. From here, since this is being the axis of rotation, very important to focus over here. Let's see the outer radius first. Outer radius is a flat line, that means it's constant. So how much is the radius? Instead of taking it up, it's better to go down. Why? Because you know it starts at 0 and 3, so outer radius is 3. What about the inner radius? Inner radius is also 3 minus this equation. Why? Because it's inside, right? 3 minus it. This is what we are revolving. So this one. So outer radius is 3 minus this inner equation. So it will be small letter ri. 3 minus, what is that? 2 minus x. So it's going to be 3 minus 2 plus x, that is 1 plus x. So this is the equation. Now you just put that in the calculator in the formula and you will get it get the answer. So I'll just erase this for a while. You can see the outer radius, what we found. Outer radius RO is 3 minus the inner radius is 1 plus x, isn't it? 3 square is 9 minus 1 plus x, the whole square. This entire thing will be squared. So this is it, and that's how you can easily get the answer. Now you put this in the calculator, you directly get this answer. But if you do the diagram, see, now let me just go back here. If you do this diagram like a rough diagram, if you write the outer radius separately, inner radius separately in detail, it's more than enough. You can just use the calculator to find the final answer. So I hope this is clear as well. Now let's do one more problem here. I hope this is in terms of, yes, this is along with respect to dy. Okay, let's do this. The region is bounded by y is equal to x squared. Now let's draw a rough graph. Y is equal to, sorry, not x squared, root x. I'm just maybe sleepy. So it's a root x. What happens? Y is equal to root x will be something like this graph. And y is equal to 2. So it's somewhere over here. Okay. And x is equal to 0. That means this part. So we have to focus on this region. And here about the y-axis, if you're doing about the y-axis, that will be like this. Again, this will be a method of a disk. It's a disk problem in question 3. Now we will not look into this. Why? If you do it along the y-axis, it's just going to be like this. Left side, sorry, also same, and it's a single thing. There is no hollow space form. But we need, if we do the part B, We need washer, right? X is equal to 4. So now this one, I think so it's less than 2. So let me just take it somewhere over here, okay? X is equal to 4 is this line. If you're rotating along this part, so this much is again over here also hollow, and then it comes like this. I hope that's clear. So this is how it looks. Now it's along the which axis? Now it's rotated x along the y-axis because x is equal to 4. It's along the y-axis it's being rotated. So this part rotates and comes over here and keeps on moving like a circle. So here limits are not along x, it's with respect to y. So we need to find this to this limit. Now what is the limit over there? We know it starts at what? X is equal to 0. Up, where is this point? 2. So it's very simple to get the limits at 0 and 2. That's it. Now, the thing is about outer radius and the inner radius. Now, it's not from down to up. It's not like this. It's the other way around. It's horizontally. So from here to here, the outer radius, how much does it? How much is it? I will take this because this is easy to understand. It's 0, x is equal to 0, this is x is equal to 4. See this part? Now, because we are rotating it along x is equal to 4, I just drew this part. But if you do the left side, only one part it's enough because we just need the radiuses, right? From here to here, outer radius RO is equal to 4. Now, what about the inner radius? It's 4 minus this equation. What is that equation exactly? Here now, you cannot write in terms of x. I can't write root x. No, why? Because we are doing with respect to y, so we need to change this. So square both the sides is going to be y square is equal to x. So x is equal to y square. I should write 4 minus y square. This is the equation. So the outer radius is 4 square minus, there is pi here, minus the inner radius, it's 4 minus y square, the whole square. This is it. So this is inner radius. It's 4 minus y square, then put the bracket and the whole square. Okay, I'll just rewrite this properly. The inner radius would be so much, but the formula states whatever is the inner or the outer radius, it must be squared. Let's use the calculator and solve it up. I've just typed this equation as it is. It's pi 0 to 2 limit 4 square minus, when there is more than one term, please use the bracket, 4 minus. There is no y term, y variable in calculators, so write it as y, but in the calculator just put it as alpha x squared whole square dx. What is the answer? It is 224 by 15 pi. Let's check the answer. See, the first one I did not do. Why? Because along the y-axis it will be a disk problem. We will see in the question 3. But here it should be, yes, that's the answer, 224 pi by 15. Please make sure you draw a rough diagram. I'm not saying for the marks or anything. It's for your own understanding, because if you don't do this graph, it'll be very hard for you to understand the outer and the inner radius, and you just can't memorize it. It's very difficult, so please try to understand this. Now similarly, you can solve the other problems. Please do them by yourselves. Now here you can see some problems. This is a disk problem, but very important to understand with respect to what. If it's with respect to y, then whatever is the equation, you need to write it as x is equal to, this goes to the other side, will be 4 minus y divided by 2. So that is what is done. But if it's along the x-axis, then you take the same equation, see, pi into 4 minus 2x the whole square as it is. But these were along the axes, so it will be a disk. See, why is it a disk? If you rotate it along the x-axis, what happens? This is the thing. There's no hollow space. If you rotate it along y, no hollow space. But if you say rotate it after certain distance, as you can see here, at y equals 4, that means over here, see, then there is hollow space formed. Y is equal to 4 means over here, see, this much is the hollow space, right? This will go up. See, the hollow space is created. So if you draw this, there will be a hollow space as well. So that's why we use the formula which we just now did. So same way, please do these problems over here. The worked out solutions are also there. Just be careful. See over here, the figure is given. So analyze the figure, understand how it's revolving, and then solve it up. Now, if at all it is say x is equal to minus 2, then at minus 2, this is 0, right? At minus 2, somewhere over here, you need to draw a line and understand this is the hollow space. Now, same thing will be over here, projected over here. So inner radius is how much? From here to here will be 2, and outer radius would be, see now this is important. What is the outer radius over here? It will be 2 plus this equation. But remember, we can't write this equation as y is equal to, because x is equal to 2 would be integral dy with respect to y, isn't it? Along y-axis, this rotation, see vertically. So we need to rearrange this plus this equation would be 4 minus y by 2. So this would be the thing. So now what we can do is we can solve it up, or you can use it directly in the calculator. So you can see this is the outer radius. Now we have simplified. So let's just simplify it. You take this denominator as 1. So let's take this as 2, and over here there's 1 times 2, it will be 4, plus this the denominator 4 minus y. The answer would be 8 minus y by 2. So you can see this is what's taken. 8 minus y by 2 the whole square minus what is the inner radius? It's just 2 minus square. Now you don't need to write this pi inside, you can just write pi outside at once. Everything like we had used just a while ago, right? So I'll just do the last part over here. As we just saw, it was at minus 2. This is x is equal to minus 2. Radius is 2. So first, inner radius is equal to 2. That's it. For the outer radius, capital RO, it would be 2 plus this equation. Why? Because see over here, from year to year it's 2, but this is going outside of that, right? So I'll write 2 plus this equation with respect to as y as the function. So we have to just rearrange this. That will be 2x is equal to 4 minus y, x is equal to 4 minus y divided by 2. So that will be 4 minus y divided by 2. Now since it is improper over here, let's make it a proper fraction. 2 is the common denominator. Over here it's nothing but 1, so it will be 1 times 2, 2 times 2 is 4, and then we have 2 times 1, so we write this as it is. It's minus y, and then what do we do is we write it as 8 minus y divided by 2. This is the outer radius. Now if you want, you can keep the outer radius like this itself and square it. That also will give you the correct answer. Now the formula is pi integral. Now what is the limits along the y-axis? It's very simple. It's 0 to 4 over here. So 0 to 4, and what you write is 8 minus y by 2 the whole square minus the inner radius is how much? 2 over here. Inner radius was 2 square. This entire thing is dy. Put this in the calculator, you will directly get the answer. So this is how we solve it. If at all you have been given the figure, it's so easy. Even if the figure is not given, you can draw a rough figure and then solve it up. Please do try more problems by yourselves. See, all the worked out solutions are there. Again, these are very simple. If there is hollow space, you would have outer radius minus inner radius. That is the method of washes. If you have only one thing squared, that means it's method of discs. So in this particular writing, you will only have method of washers. They have clearly mentioned washer part, so it will be outer radius minus inner radius. So only focus on those problems. And over here as well. And last problem over here, all the answers are there. Please do solve that. So that is the end of this particular topic, question number 17. I hope this is clear. If you have any doubts, do post them in the comments. Please be careful along which axis. I'll just reiterate again. Now, if at all the rotation is along the x-axis like this, x-axis means either it can be x-axis or y is equal to 2 or y is equal to minus 1. Then the formula will be with respect to x as a function of x. It will be dx over here. Okay, so all this over here, whatever is there, it will be as 1/4 x square, or it will be minus 2x the whole square. I'm just giving a random example. It must be in terms of x. What is the limit here? Limit is along the x-axis from 0 to 2 like this, along x-axis. But if it is along the y-axis, or we have x is equal to 2, x is equal to minus 3, that means here it's like this, along this axis, or over here. When it's rotated like that, the formula will be integral. Here it will be with respect to y, so it should be y squared minus 2y, something like this, with respect to dy. So this is very important, and the limits over here is on the y-axis from here 0 to whatever, wherever it's ending upwards, that will be 0 to 4. So please understand the differentiation on that. From the question itself, we should understand that, and then you can solve it easily.